Now, the algorithm that I want to look at today is an alternative for traditional long division. First, let's set up our problem. We're going to have 216 divided by 8. Okay, so first things first, we're going to set this up for long division. Now, traditionally, the first place that teachers go wrong when we're trying to teach kids to divide is we ask them, well, how many times can 8 go into 2? How many times can 8 go into 21? We set the problem up the wrong way by asking the wrong question. We're not putting 8 into 2. We're putting 8 into 216. Okay, by asking how many times 8 goes into 2, that's really a nonsense question. So there's really no wonder why our students are confused when we ask them to do long division. We're asking the wrong questions. We're confusing them. So the beauty of this method is there is no wrong answer unless the student goes too high. So we'll start the lesson by asking the class how many times 8 can go into 216. So a kid in the back raises his hand and says 10. Great, you write down 10. Okay, there is no wrong answer. 10 times 8 is 80. We subtract and we ask how many times 8 can go into 136. Same kid raises his hand and says 10 again. Fine, you write 10. 10 times 8 is 80. We subtract, we get 56, okay? And this continues until we get the correct answer. Another kid guesses 2. 2 times 8 is 16, we get 40. Finally, another kid guesses 5. 5 times 8 is 40, and we're done. In order to get the correct answer, the student needs to add up the partitions of the quotient, and we'll get 27, which is the correct answer. Now, this method can also be used with remainders, okay? Remainders, decimals, decimal fractions, whatever you want to call them. So let's say we have 363 divided by 9. Again, students are going to guess. Let's say this time the student guesses 20. So we write down 20 where it belongs over the 63. 20 times 9 is 180. We subtract, we get 183. Another student guesses 20 again. 20 times 9, we get 180. And we're left with 3. So our final answer, we add up the two 20s, we'll get 40. And 3 over 9, or 40 and 1/3. In any case, it's a lot easier for kids to use this method than to try to correctly guess the first number the first time that you ask them to do long division. That correct guess, you're either right the first time or you can't do the problem at all, is the reason a lot of kids just quit and give up on trying to do long division at all. This method you can use to build some success, and then if you want, you can work your way towards the traditional long division algorithm.